In this part of the Computational Intelligence course related to fuzzy systems, we continue fuzzy controllers. We will consider first the architecture of a fuzzy controller, and then we will continue with rule evaluation for the measured inputs. The rule evaluation results in a fuzzy set for the output, which should be defuzzified for obtaining crisp values as the controller output. Here is the architecture of a fuzzy controller. The upper part is corresponding to the controller, and the lower part is corresponding to the environment which is to be controlled. In the environment part, the controller should produce a controller output which controls the system. And from this environment, we measure some values, and accordingly, the output of the controller is decided. This part is not fuzzy. The control variable value and also measured values are crisp. In the fuzzy controller, we have fuzzification interface, which receives current input value and eventually maps it to suitable domain. It converts input value into linguistic term or into fuzzy set. Knowledge base consists of database and rule base. Database contains information about boundaries, possible domain transformations, and fuzzy sets with corresponding linguistic terms. And rule base contains linguistic control rules. The decision logic uses the information coming from the fuzzification interface and also from the knowledge base. It computes output from measured input according to the knowledge base. Here the information is fuzzy, and whatever produced by the decision logic is also fuzzy. The fuzzification interface determines crisp output value and eventually maps it back to the appropriate domain, and it is used controlling the system. Remember our cardboard problem. Here there is an inverted pendulum. There is a mass M at the head of the pendulum, and the angle between the vertical axis is called theta. The length of the rod is L, and the mass of this leg is M. We are trying to find the amount of force to be applied here such that the angle theta becomes 0. So pendulum is vertical. And for theta and theta prime, we defined fuzzy sets. We assume that theta is between minus 90 and plus 90. X1, which is corresponding to theta, is partitioned into 7 fuzzy sets, which are negative big, negative medium, negative small, approximately 0, positive small, positive medium, and positive big, as we have seen previously. Support of fuzzy sets are intervals with length 1/5 of whole range for x1, that is theta, and similar fuzzy partitions for x2, which is theta prime, and also for the output, which is y, is applied. The next step is to specify rules to develop the controller, fuzzy controller, and these rules are in the form if psi1 is A, this is a fuzzy set, and in fact this is a term, linguistic term corresponding to a fuzzy set, and psi2 is A2 and psi-n is an, then eta is b. This is corresponding to output, and these are inputs. A1 up to an, and b represent linguistic terms corresponding to fuzzy sets. Mu1 up to mu(n) are the membership functions for these fuzzy sets, and mu is the membership function for the fuzzy set corresponding to b, according to reference sets x1 up to xn and y. x1 is the reference set for fuzzy set 1, and xn is the reference set for fuzzy set mu(n). And y is the reference set for the output. And like this, we have k rules. The rule base consists of k rules. Consider these 19 rules developed by an expert for the control of the card ball. For example, here we have theta, negative big, negative medium, negative small, approximately 0, positive small, positive medium, and positive big. And similarly, for the derivative of theta, we have the same fuzziness as negative big or positive big, etc. And here we have the rules for the control of the card pole. Consider this column and row. This is saying that if theta is approximately 0, if theta is approximately 0, and theta prime is negative medium, then F, the force, is positive medium. We have measurements on the reference sets x1 up to xn. The measured values are written here, which are x1 up to xn. These are forwarded, these values, this tuple is forwarded to decision logic. Consider rule: if psi1 is a1 and psi n is an, then theta is b. Decision logic computes degree to psi1 up to psi n fulfills premise of rule. That is, j from 1 up to n, the value of the membership j on set reference set xj is calculated. Here the value is xj, which is the measured value as given here. This is calculated. Combine premise values conjunctively by taking the minimum of the membership values found here and call this one as alpha. And instead of a single rule, we have k rules similar to that we considered for a single rule. The premise value should be calculated. This is the minimum of the membership values for the measured inputs for that rule. For a single rule, output of the rule R, this is a fuzzy set of output values. Thus, cutting of fuzzy set mu IR associated with conclusion of rule R at alpha R. So for input, which is the tuple containing x1 up to xn, the rule R implies fuzzy set. This is the implied fuzzy set by the rule R. It is a mapping from the reference set of the output to the interval 0, 1. We are finding the minimum of the membership values for each set considered in the rule R. For the set from 1 up to n, defined on this references calculated at the points x1 up to xn. And here we are considering the membership value for the corresponding output. And we are finding the minimum value. So for rule R, by using this minimum on the membership function for the output, we cut with alpha. So this is the corresponding fuzzy set for output of the fuzzy rule R. Consider the special cases. If each membership value given here is 1, these are the membership values we considered here, all has value 1, then this function, this membership function for the output determines the output value. However, if all these membership values are 0, then the output by that rule will be 0. Consider as an example, consider again cardboard problem, the rules given for the cardboard problem. Assume that the measured values for the inputs theta and theta prime are 25 and -4. And in that case, we are trying to find out what should be the output y for the control of the environment. For theta 25, we are considering here is 25, and we are considering the fuzzy sets defined on theta, and we see that for the theta value 25, we have a membership for positive small and also a membership value which is greater than 0 for positive medium. For all the other fuzzy sets, the membership value is 0. So for theta equal to 25, we have to consider positive small and positive medium. This is positive small and positive medium. And for positive small at 25, the value is 0.3, and for positive medium at 25, assume that the value is 0.6, for all others are 0. And also we have to consider the fuzzy sets defined on theta prime, the derivative of theta prime, and the measured value is -4. And remember that we assume that it's changing from -45 up to 45 for theta prime, and assume that for -4 we are at this point, and the value of the negative small is 0.5, and the value for the approximately 0 is 0.5. So from the membership functions, we see that membership for negative small is 0.5, membership for the approximately 0 at -4 is 0.5, and for all the others it is 0. So indicated for cells should be considered, and these are marked with red here. We have positive small, positive medium for theta, and negative small and approximately 0 for theta prime, and we have these 4 cells. But notice that here only 2 rules are written by the expert. There is no rule for these 2 cases, but only 2 of them are defined as rules. So we are considering only these 2 rules, and this is saying that if theta is positive small, and theta prime is approximately 0, then the force should be positive small. And this one is saying that if theta is positive medium and theta prime is approximately 0, then the force should be positive medium. We have to consider these two rules. Consider the rule 1. Rule 1 is saying that if theta is positive small and theta prime is approximately 0, then f is positive small. So, this is the fuzzy set on theta, saying that we have 25 and we are considering the positive small. The value is 0.3, membership value is 0.3. And we are considering also the fuzzy set on theta prime. This is on theta, approximately 0. We have minus 4 here, and the value of the membership is 0.5. And we are taking the minimum of these two. This is 0.3 and this is 0.5. So we have 0.3 as the minimum of these two. And then we are considering the fuzzy set positive small. We are comparing the value of the membership with the minimum of these two. That means that if the value is smaller than 0.3, we are considering the membership value of the positive small. Otherwise, we are using this one. We are cutting that point. So we have 0.3 as the membership value of the output. This is the premise for the rule. So notice that for the output, by this rule, rule 1, we are obtaining a fuzzy set on F. Now consider the second rule. The second rule is saying that if theta is positive medium and theta prime is approximately 0, then F is positive medium. So we are considering positive medium at 25. Theta is 25. So we have the membership value 0.6 at this point. And also for theta prime, we are considering the fuzzy set approximately 0, that's one. And the value at minus 4, this is the measured value, is 0.5. So we are using the minimum of these two, it is 0.5. And this is the membership function for positive medium. And we are considering the minimum of the value found here, which is 0.5, and the value of the membership. So up to this point, the membership value is smaller, so it is the minimum. And between this interval, we are using the minimum of the value 0.5 and the membership value. So we have 0.5 here. And after that, again, the value of the membership is used because it is smaller than 0.5. So this is another fuzzy set defined on F, reference set F. This is going to be used as well. We have these two rules, and from these rules, we obtained these two fuzzy sets. We are using the union of these two sets. We are using the maximum value among these two sets. So up to this point, because the membership value for the second fuzzy set is 0, we are following this fuzzy set. However, after this point here, the membership value for the second fuzzy set becomes larger than the value here. So it is following the second fuzzy set. So we have such a fuzzy set for the output. What we have considered here is the rule evaluation for Mandani Asilian controller. The input tuple 25 minus 4 leads to fuzzy output as we have found here. But the crisp output is needed for controlling the environment, so it should be determined by the depacification.